Honors Geometry, Section 13.4 Notes, Internal, External Tangents. Inscribed angle. This is when it's on the circle. Now this is directly related to what we did in the previous section. If a tangent and a secant, or chord, intersect at a point on the circle, then the measure of each angle formed is the measure of half the intercepted arc. So, just like we had in the previous section, this can be thought of as an inscribed angle. It's going to be half the measure of its intercepted arc. So the measure of angle 1 is going to be half the measure of arc BRD. Likewise, measure of angle 2 is going to be half the measure of its intercepted arc, arc BD. Let's try to put this into practice. Find the measure of angle 1. Well, we have a chord and a tangent intersecting at the point of tangency. So the measure of angle 1 is exactly half the intercepted arc. That makes that 56 degrees. Then we have two tangents, or two secants that intersect, could be two chords as well, in the interior of the circle, as the picture shows. Then the measure of each angle formed, and they're going to be the same angle because they're vertical angles, is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. I'm shading in the two arcs that we're adding together. The measure of angle AEB is the average, half the sum of the measure of arc AB and the measure of arc CD. Let's put this into practice. Number 2, X, which is an angle formed by two chords intersecting inside the circle, is going to equal half the sum of 55 and the arc of the vertical angle, 107. 55 and 107 is 162. That's going to give us 81 degrees for X. So we got when they intersect on the circle, we got when they intersect inside the circle. Now we have a situation where the two secants intersect on the exterior of the circle. If any combination of secants and tangents intersect in the exterior of a circle, then the measure of each, the angle formed, then the measure of each, that's not written right, then the measure of the angle formed is 1/2 the difference of the measures of the arc of the measures of intercepted arcs. This is a typing error nightmare here. My apologies. So here's what that means. The measure of angle CED, that's this angle right here, is going to be half the difference of arc AB minus the measure of arc CD. Which one goes first? The one that's bigger. And the one that's bigger is the one that's furthest away. So this is obviously bigger than this little fella. Put this into practice. X should be equal to half of the difference of 93 and 29. 93 minus 29 is 64. Half of 64 is 32. So once again, we got three scenarios. The intersection happens on the circle. then the angle in question is half of the intercepted arc. Intersection happens in the circle, then the angle in question is 1/2 the sum of the intercepted arcs. The intersection happens on the outside of the circle, and the angle in question is 1/2 of the difference of the intercepted arcs. All right, question 4, find the measure of x. Well, x and 78 combined make up the entire circle. So there's lots of ways to go at this, but we could say that x plus 78 is 360, which makes x 204. That's not 204. 78 taken away from x, or from 360, it's not 204. I apologize. $78 from 360 is 282. I wasn't even close. What I had written on my paper was bogus. The measure of angle 1 should be half of that. Because we have a segment, a secant, and a tangent intersecting on the circle. It's an inscribed angle. Should be half of 282, which is 141. Number 5, we have two chords intersecting on the interior of the circle. So 71 has to be half of the sum of the two intercepted arcs. So lots of ways to solve the equation. We could distribute the half, or if we recognize there's only two terms in this equation, we could just multiply both sides by 2 and get 142 is 92 plus x. We subtract 92 from both sides, we're going to get x is 50. Number 6, we have two chords intersecting on the exterior of the circle. So the angle formed by those two chords is going to be half of the difference of the two intersected arcs. If I multiply both sides by 2 again to get rid of this half, and then if I subtract 168 from both sides and then divide by -1, I get x is 50. X is not always 50, by the way. Coincidence? Number 7, 118 should be half of y, which means if you multiply both sides by 2, you get 236 is y. 236 in x has to be 360, because that's completely around the circle. And that makes x 124. Number 8, let's see. So the theorem that we have with x relates to this arc and this arc. So let's ignore x for now, and let's just throw a y in here and figure out what y is. Y, which is an angle formed by the intersection of two secants inside the circle, should be equal to half of the sum of 82 and 146. 82 and 146 is 228. Half of 228 is 114. So if y is 114, so it's this vertical angle, y is not even in this problem, we added it in. X plus 114 has to be 180, that's a supplement theorem, which makes x 66. Number 9, we could figure out y first. Y plus 93 plus 183 is 360. will give us y plus 276 is 360, which is going to make y 64. Oops, it's going to make it 84. Something didn't feel right about that. So if y is 84, x, which is an angle formed on the exterior of a secant and a tangent, is going to be half of the difference of 183 and 84, which is half of 99, which is 49.5. This is not easy. I'm not suggesting that it is, but there are 3 different theorems applied with all the other stuff that we've learned throughout the year. This is a pretty tough lesson. Please do the homework for 13.4.